We'll discuss chapter 11. Um, some physical phenomena, temperature, volume, capacity, actually pressure. We can measure temperature, volume, pressure using scalars with the numbers. Number will give a size basically. For example, this is a beaker. There are 40 milliliter here, 40 milliliter water. Then I'll add another 10 milliliter. Now total is 40 plus 10. This is 50 milliliter. So two sizes. Likewise, but some physical phenomena like wind, we need not only the size, but we also need the direction. Um, for example, okay, assume if I tell 200 km per hour, the wind, the wind speed is 200 kilometer per hour, so you don't feel it. But if I tell that it's 200 kilometer per hour, a wind is coming towards you, what will happen? So it make a big effect on you. This is 200 kilometers up, or it's come towards the country, then it is going to be a storm. It's make a big effect. So the direction is very important for a pilot, for a plane. Uh, Wind direction is very important. If they have a tailwind, they are very happy because it's supposed to for the flying and it saves the fuel. But if they have headwind, so it wastes a lot of fuel. So the direction is very important. Hence, in our environment, for certain phenomena we can explain, we can measure with the scales. For someone, we need not only scale but also a direction. So now we need something to visualize this. Show this one. Uh, Geometric object. So the geometric object is a line segment. And we need for this line segment in length of a line segment imply what? Size, or the good word is magnitude. Now where's the direction? Direction is with the arrow. So arrow arrow imply the direction. So this setup is a vector. A vector has a direction and a magnitude. Some quantities we need required size and a direction, or the magnitude and a direction to measure. So those are vector quantities. Others were scalar quantities. For example, temperature, volume. Those are scalar quantities. Vector quantities are velocity, acceleration, force. So those are vector quantities. Now, so this is the best visualization. This is the visualization for a vector. So we'll give more meaning for it by giving two letters. So now AB vector. We give a name to this vector. Now we can write AB vector. Now give we can write arrow on top, then more meaningful, A to B. We give the direction on this small letter with these two letters. Also, a different way of doing it. We will give us simple letter with bold face. Let's say this is A. Or maybe B. Not just B, you have to write in a bold face. So that's how we can visualize a vector. So we can draw and give a direction. On top of we can give two letters, and we can write as well. This will imply A to B, or we can write like this B, and we can write this one as well. A to B is B. We will write differently. A to B vector is we name differently B. Then A to B is B. Then B to A is what? B to A is then minus B. If you change the direction, it's become minus B. How do we draw this one? So we'll write A, B, and we put the opposite direction, and we put minus B. If it goes to A to B, it is B. Now it is coming to opposite direction. So then it has to be minus B. Now what is a similar vector? Or let's say equal vector. Equal vector. Equal vector means if two vectors have same direction and same size or same magnitude, then we call that is they are equal vectors. Assume that AB and another vector PQ. If I tell AB and PQ are equal, what is the meaning of that? The meaning of that, the size of this same magnitude and same direction. Now, how do you show magnitude by a symbol? Magnitude by a symbol. Relevant. Okay, I will take this vector. How I express the magnitude of AB? The magnitude of AB. So we can write simply AB with two lines, usually like mod. What is the meaning of that? Size of AB, the magnitude of AB. If we have a symbol like this AOB, then magnitude, the magnitude of A is, you can write like this. So we replace the word magnitude by uh, inserting two lines besides. If I ask question differently, show that AB and PQ are similar or equal vectors. AB and PQ are equal vectors. How do you show this one? To become equal, what are the requirement? Magnitude and the direction, same direction and same magnitude. Then you have to bring a ruler and you measure this one. Okay, that is 20 centimeter. This is also 20 centimeter. Then you are writing magnitude of AB and equal 20, magnitude of PQ equal 20, hence AB magnitude and PQ magnitude are same. Then direction. One is done, one requirement. Magnitude. What is the other one? Direction. Then you want to show that these lines are parallel. If they are parallel, then the direction is same. Now you are telling AB parallel to PQ. Now the both requirement match, hence AB and PQ are similar equal vectors. This is A, B, C, D. Now A, B, C, D is a parallelogram. Right? It's a parallelogram, and show that AD and BC are equal vectors. So how do you show AD and BC are equal vectors? This is a parallelogram. So what is the requirement? We want to show that AB size is same, length is same, and we'll do like this. Consider AD vector and BC vector. Now we want to show that this is equal vectors. So we can tell that AD equal BC. Why? Because parallelogram. Because we know that AD equal to BC size and AD parallel to BC because parallelogram. Hence AD equal to BC. Same as you can show AB is equal vector to DC equal vector. Let's find parallelograms. Sorry, this is a hexagon. This is a regular hexagon. Uh, and I'll take A, B, C, D, E, F. What do you know about regular hexagon? Those are parallels. And those are parallels. And this one is parallel. Now, what is the parallel vector F? Equal vectors. So when you look at this is a parallelogram, and so AF is equal to BO, and also AF equal to OE, and BO and OE also. BO and OE also parallel, because same direction, it is overlap and same length. And AF and DC, AF equal to DC, equal. Basically you can write in one go AF equal to BO equal to OE equal to CD. They all are equals. If you take this is A, this is also A, this is also A, this is also A. And FE, FE equal to EO equal to OD equal to BC. If you take this is B, this is also B, this is also B, and this is also B. If this is C and this is also C and this is C, this is C, it means AB equal to FO equal to OC equal to ED. Now let's consider scalar quantities and vector quantities. Now volume, right? As I discussed earlier, I put 30 ml and another 10 ml, so total is 40. 30 plus 10, I can simply add equal 40. But vector quantities you can't add like this. If you have, we had 10 direction, okay, this is A, and if we have B to this direction, right? So you can't simply add. You can write A plus B, but what is the direction? So then we have to use a rule for this one. So that is where, so vector addition under triangle law. What is the vector addition of triangle law? It means to add two vectors, you need a triangle. Assume if we have a vector like this, AB, then other vector like this BC, then how do you add AB plus AC? The addition will show, if you complete this triangle, an addition will show from AC. In other way, if you add AB and BC, what is the answer? Answer is AC. Now I'll write it is here. So AB plus BC, what is the final answer? AC. What will happen if we have something like this? You have AB here. Now you have BC, uh, PQ here. Now I want to add AB plus PQ. How do you do? Then you can create. Now I want to bring this AB and PQ into a triangle. So I'll leave as AB here. Then I'll measure this one PQ and I'll draw a parallel line through B because AB plus P. So B and P should be together. So I will draw a parallel line to this one. Is those two are parallel? Yes. Then I'll measure this length here. I'll mark here. Now PQ and I will write this is D. Now what you can tell about PQ vector and BD vector? They are equal vectors because we draw parallelly and we measure the length. We measure the length by using this one. We measure the length, same direction. This now I bring it to here. Now this is in a triangle now. Now I can write AB plus PQ mean A is equal to AB plus BD. Reason BD equal to PQ. Then AB plus BD mean what is the final answer? AD. Or else I can work the other way around. This is AB and this is PQ. This is AB and this is PQ. I will create a similar vector to here. Still it's work. So I will measure this. I'll do a parallel line first. Right. So those are parallel now. Then from here I will measure this distance. Same. So I'll write this is D. This is Q. Now AB and DP are similar. AB equal to DP. What is the AB and DP are equal? I mean AB DP are equal vectors. Now it is in a triangle. Now I can apply triangle law. Now by triangle law I can complete the triangle. So this is the answer. DP plus PQ is DQ. I can write in terms of this one. This is A and this is B, bold. I will write like this underneath a symbol, then you know that is A. So what is AC? What is the total? Total mean A plus B. So this is A plus B. For which direction? This direction. Assume if I have this kind of. AB, BC, CD. Three vectors. I want to find what is AD. Then there is no triangle to apply the rule. So I make a triangle here. This is one base, this is another one. Okay, this is a triangle. Now consider ABC triangle. Now from ABC triangle, AC is AB plus BC. Now I know AC value. Then I consider this triangle. Consider ACD triangle. Then AD is what? AC plus AD. Do you know AC? Yes, AC means AB plus BC plus CD. So this is we applied two times triangle law. What is the summary of this one? What is AB mean? AD mean? AD mean AB plus BC plus CD. So you can simply write, but this is the proof. When you give proof, so you want to consider the addition only can happen through triangle law. To apply triangle law, I need two triangles. So I create triangles and I did. So what is other thing? If you want to go to AD from A to D, so you can go to AB first, then BC, and then CD. Let's discuss question number example 4 in the exercise book, textbook. Um, so we want to find PS. Now A to B, B to C, now AC. So how do you find AC? You go to AB and BC. That's how you want to think other way around. What is AC mean? You go to AB and then BC. So AC mean AB plus BC. The law is if we have like this AB and BC, then you can write the answer as AC. Now we learn this one. Now we are using it is the opposite now. If we want to find AC, what is the meaning of that? This one plus this one. AB plus BC. Now I want to find PS like this. PS mean what? Now I need a triangle. I have two triangles, but this triangle is more meaningful. Why? Because I have A and C. Now I can write PS mean PQ plus QS. PQ plus QS. Now QS I know it is C. I know PQ. Sorry. I know QP is A. What is PQ mean? PQ mean minus A. Then this is become minus A. So answer is minus A plus C, or you can write C minus A. Now the part 2 RP. So then R This is actually R. So RP. Now this is the vector. Now I want to bring to a triangle. Now RP mean RQ plus QP. So RQ mean minus B. QP mean A minus B. A minus B. Now I know RP as well. The third one PT. PT. PT mean you can write PQ plus QR plus PQ plus QR plus RT. Now yes, it's not a triangle. Actually you can see that PQ plus QR and PR. So first of all we want to find PR. So PQ plus QR mean what? PR. So now this is a triangle. And then when you know PR, PT mean PR plus RT. This is the another triangle. PR and RT is the other triangle. Two triangle is there, but we can write straight and it is easy. So PQ mean minus A, QR mean B, and RT mean D. You can work like this as well. PT mean PR plus RT. Now you know RP. This is A minus B. Then you know RP this one. Then PR mean what? Minus A minus B plus RT. RT mean D. So minus A plus B plus D. Still the same answer. B plus D minus A. Last one is TS. TS you can come TP plus PS. Because TP already know. PT you know mean TP you know minus of this one. And PS already know. Or the other way around. TR RQ. So first of all you find TQ. Then TQ plus QS. You can write everything TR RQ QS. So TR is minus D. Because RT is D, then TR is minus D, then this is minus B, and QS. Do we know QS? Is C. Let's see. Now we did vector addition. Then, okay, vector subtraction. So I'll just gloss this one. Right, so since this is A, this is B, A, B, C, D. Okay. AC from parallelogram. This is a parallelogram. Right. What is AC? AC means, so this is B and this is equivalent to this is also B. AC means AB plus BC, which is A plus B. What is DB mean? this one. dB mean dA plus AB. So dA mean minus B. AB mean plus A. So this is A minus B. So this is a vector subtraction. This is just to give an idea. And vector addition we complete. Now vector multiplication. Now I have a vector A here. Vector A here. Another vector B. A multiplied by B. There's no meaning. We can't do. There's no vector multiplication. Only what we can do, we can multiply by vector. We can multiply by a scalar. Vector multiplied by a scalar. Scalar means a number. Assume we have a vector A. I multiply by this vector A by 2 number. So this is become 2A. What is the meaning of that? So you are making this vector another A. So this is also A. This is also A. So what is this vector? 2A. I'll put so you stretch this vector or this expand this vector by 2 by multiplying by 2. If we multiply by 3, so this is 3A. It means 1, 2, 3. So this kind of 3 times. So this is going to be 3A. Same direction. And if you multiply by half, what direction, what is the command? Half A. Make it shorter. Half of it. So this is half A. So that's the only thing you can do for a scalar. If you multiply by minus 1, minus A, it means you give a command to reverse it. Minus A. If you multiply by minus 2, it's minus 2A. It means same size, 1, like this, same size, but you have to reverse it. So this is minus 2A. That's the only thing you can do. Assume I will do this kind of one. So they are parallel. Now, can you write this length or the vector in terms of A? They are parallel. So it can it be 2A no more than 3A? Okay, I will explain something like this. It kind of 3.5 or something A. So we can simply write lambda A. So what can you tell about this lambda? This lambda is greater than 1 or less than 1. So lambda has to be greater than 1 because when I look at this one is bigger than this one, then lambda greater than 1. If I draw this one parallelly, and if I write lambda A here, so what kind of lambda is this? Lambda is less than 1 because it is less than the uh, A size. So likewise, I can change the size by multiplying a scale of a vector multiplying a vector by a scale, I can change the size as well as I can change the direction. If it is positive, it is same direction. If it is negative, it is other direction. Now, what is the use of it? Assume that you have a triangle like this. So A, B, C. So AB is A, and BC, AC is B. So I'll get the midpoint. That's how I write in the middle. And this one the midpoint of AC. It means I am telling that this side and this side is equal by putting two lines. I am writing this side and this side equal putting three line because two and three because I can't put the same symbol. Right? Now I put this is P and Q. Now what is AB? AB is E. What is AP? You can write AP is, can you see this is half of AB? Then can you write half of A this one? So AP has the same direction as AB, and we know that this is half and half. So AP is half of A. Same as PB. What is PB? PB also half of A. So I'll give the proof for this one. Okay. AP plus PB is AB. But AP and PB are equal vectors. Why? AP and PB are equal vectors. Why? Because AP and PB has to become equal vectors. What is the requirement? Same direction and same size. So AP and PB have same size. AP and PB are same size. And AP is parallel to PB, same direction. Now this is parallel, and if it this is actually those two parallel, what will happen? This line become an overlap on this one. Then it's still parallel. It is overlap but parallel. Now insert AP plus PB equal AP. Now AP and PB are same equal vectors. Now I can write AP plus, instead of PB I am writing AP again. Why? Equal. So what is AB value now? AB value is A. So AP plus AP, 2AP equal A. So AP equal to cross multiply A divided by 2. Same as I can use this one as well. I will show from here. So I'll write the same thing. AB equal AP plus PB. Now I write AP plus AP because I need AP. Now I am writing, I drop AP. Instead of AP, I write PB. Is AP equal to PB? Yes, they are equal vectors. Plus PB equal AB mean A. Now 2PB mean A. PB mean A divided by 2. So vector addition done. Vector multiplication now meaning and vector multiplied by a scalar mean number. Yeah, that's done now. I'll do a bit of extension to this sum. So now AP is half A. I'll write from here half A. B, this is also half A. Same as this is whole B and this is mid. So this is half a B and this is half a B. Now I want to find a PQ. PQ mean PA plus AP. AQ. So PA is what? Minus half A. AQ is plus half a B. When you factorize half a B minus A. Now this AB is A as usual. I'll break in this one 1 to 3. D is here. So I will tell AD to DB 1 to 3 ratio. What is AD and what is DB? So this is 1 and this is 3. It means total 4. Right? So AD means 1 out of 4. What is the E? And DB means 3 out of 4 with from A vector. So if you break 1 to 3, that's how you want to do. So my question is, this is A, this is B. What is A plus B? So A plus B is this. My next question is 2A plus 2B is 2A plus 2B parallel to A plus B. So this is A, another A, 2A. This is 2A and 2B. Another B and another B. So this is 2B. So then what is this one? This is 2A, this is 2B. It means 2A plus 2B. This one. Now you can see A plus B and 2A plus B is overlap. It means they are in the same direction. Yeah, it is mean parallel. Parallel and a special location. It is overlap as well. A plus B. What are the multiple of A plus B? 2 times A plus B, which is 2A plus 2B. 3 times A plus B. 3A plus 3B. Half times A plus B. Half times A, half times B. Now you know that 2A plus 2B and A plus B are parallel. A plus B and 2A plus B parallel. So In other way, you write, if you can write 2a plus 2b as a multiple of a plus b, 3a plus 3b, you can write multiple of a plus b. That is 3 times. Half a plus b, you can write multiple of a plus b. It means they all parallel. A plus b all parallel to 2a plus 2b. Uh, a plus b parallel to 3a plus 3b. A plus b parallel to half a plus half a b. Even if you reverse by multiplying minus 1 or minus half, still a plus b parallel to minus half a minus half a b. But parallel, it is opposite direction. If it is positive, yes, it is same direction. In example 4, we want to show that 6a plus 8b and 9a plus 12b are parallel. So what we need to do, we want to write as a multiple. Now I can write this one 3 over 2. So this one divide by 2 and multiply by 3. 6a plus 8b. I can write this one as a multiple of 6a plus 8b. Hence 9a plus 12b is parallel to 6a plus 8b. If you can write something, a vector is a multiple of another, then those two vectors are parallel. We discuss vector addition, then vector multiplied by a scalar factor, and vector subtraction. Just to give a right idea, we already used this concept. If we have a here and if we have uh, b here, so a minus b means we turn this one the other way around because I can't put the triangle low. So I turn the other way around by I reverse this one by putting minus b. Now I will add this one a plus minus b, a minus b. For example, assume that if you have a here, you have b here. Now what is a minus b? A minus b vector. You want minus b, right? Okay, turn the other way around. So this is going to be minus b. Now write a similar vector to here. Draw a similar equal vector. This is minus b. Now use the triangle law. A plus minus b. A minus b. Last one. What is zero vector? Zero vector is if we have a vector AB, AB plus BA. This is the zero vector. Proof is AB and BA I can write minus AB. BA I can write minus AB. So AB minus AB cancel out this one. AB plus BA zero vector. Yes. plus a minus a is a zero vector. Yes. Another way now. What is zero vector? AB plus BA.